Hi everyone, today we're going to talk about your final way to solve quadratics, the quadratic formula. The quadratic formula uses variables a, b, and c to represent constants in standard form of the quadratic equation. So if we remember, standard form of a quadratic is y equals ax squared plus bx plus c. So you will see a, b, and c in the definition in the quadratic formula here, and that's where the a, b, and c comes from. So the quadratic formula is defined as x equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. There is a song, if you want to look it up on YouTube, I'll save you by not singing it right now. The quadratic formula solves all quadratics, any quadratic. However, it takes a while. So we will learn later on when it is appropriate to apply this method and when we should use our other methods that we've previously learned to kind of speed up our work. Because we're practicing the quadratic formula, it's important we know how to use it. Your first step in solving any quadratic equation is to set it equal to 0. When your equation is equal to 0, it makes it easiest to assess what method you're using. Now, we are being told to use the quadratic formula today. Then we factor out a GCF. Makes your number smaller. It's easier. If your GCF is anything other than 1, you're going to divide it out. Then substitute into the quadratic formula. At the end, you want to look at your answer and simplify your final answer if you can. If it's complex, you want to divide out a common factor if it's true for all parts of the answer. If it's not complex, you better give us 2 rational answers. We're going to work through 2 examples today using the quadratic formula. First step, set it equal to 0. I like to keep my x squared positive, so I am going to move over to the left-hand side. Adding like terms where appropriate, putting it in standard form. This shows me that a is equal to 3, b is equal to negative 10, and c is equal to positive 10. There's no common factor there to divide out, so we have what we have. Substitute into your equation. X equals negative b, negative times a negative is a positive, plus or minus the square root of b squared minus 4ac, all over 2 times a. Now, it really is up to you how much work you show. You are going to be allowed to use your calculator as support, but you do want to keep yourself organized and keep your answers exact. We cannot have decimals when we're solving quadratics. We're talking fractions and roots, please. When I show my work, I always show the substitution. Then I simplify the roots. So the next thing I'm going to do is negative 10 squared minus 4 times 3 times 10. So this is plus or minus the square root of negative 20. And then over 6. I always show this much work at least. We know with radicals, we definitely can't leave a negative under a radical. So that negative coming out of the square root is going to come out as I. We also want to take out any perfect square we see. So this negative square root of 20 is actually 2i square roots of 5 over 6. After all that simplification, you do come to your final answer. However, we have a GCF of 2 in the 10, the 2i, and the 6. All 3 of the outside terms share a 2. Therefore, to get our final answer, we want to divide all of our terms by 2. So our final answer is actually 5 plus or minus I square roots of 5 over 3. 2 solutions to our quadratic equation. All right, we are approaching another quadratic equation. So we're going to set it equal to 0 to solve. Again, I really like to keep my x squared term positive, or n squared in this case. So I'm going to move over to the left. My b term cancels out, so I'm left with 5n squared minus 125. There's a GCF of 5 here, so I'm going to take that out. If I can work with smaller numbers, I should. And I'm going to divide both sides by 5 to get rid of it. So I've simplified my equation down to n squared minus 25 equals 0. And it's time for me to apply the quadratic formula. I need to identify a, b, and c. A is equal to 1 here. There is no b term, so b would be equal to 0. And then c is equal to negative 25. I always show the substitution into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2 times a. Simplify as much as you can. Well, the first term here is going to be 0 plus or minus square root of 100 over 2. So 0 plus or minus 10, square root of 100 is 10 over 2, just turns into 0 plus 10 over 2 and 0 minus 10 over 2. So our solutions to this quadratic equation are negative 5 and 5. If it works out evenly, you do have to write them as 2 separate answers. If you have an I or a square root left in your answer, feel free to leave it in the plus or minus notation. We really just want it as simple as your answer can get.